My name is Ritvik Rustagi, and I am the owner of TMAS Academy. Welcome, everyone. And now we will be doing Unit 2 of AP Physics 1 Dynamics. Now, if you haven't already, please go to the description right now and get the free AP Physics 1 book that I wrote. Now, that book has everything you need to know to get a 5 and an A. It has tons of practice problems, and it has all the concepts that you will find on this exam. Now, let's get started. Contact forces. You've definitely done something in real life that involves contact forces. For example, pushing a friend or pushing a suitcase. So a contact force is when two objects are in direct contact with each other. For example, friction force, because we might have like a box and the surface, the ground being in contact with each other. Tension force, which is basically from a rope or a string tied to an object. Normal force, because normal force is perpendicular to a surface. You have to be in contact with the surface for a normal force to occur. Then there's spring force, and spring force is a contact force because you're in contact with what? The spring. And applied force, because that's in the name, right? Maybe someone's applying force with their hands, right? So their hands are in contact with an object. Now there's another type of force that we will always see in this course: field forces. Now field forces are different because the two objects do not have to be in contact with each other. Gravitational force will be the force you will be dealing with in this course. That is a field force. There's also magnetic and electric, but don't worry about that. That's not for AP Physics 1. Now, some people might be wondering, why is gravitational force a field force? So I'll give you an example to prove that. When you throw a ball in the air, maybe a tennis ball, it comes down immediately, right? It will come down, right? But it's not in contact with anything. But it's because of Earth's gravitational field. It's not in contact with Earth, that tennis ball, but there's still a gravitational force on it. And that's why it's a field force. Now let's go deeper into gravitational fields and forces. The gravitational field is denoted by G, lowercase g. An object with mass m will have a gravitational force of mg. That is the product of mass and the gravitational field. Now, gravitational force on Earth is given a special name, weight. Now, some problems might ask you to conduct an experiment to find the gravitational field. Now, to do that, you measure the force and you measure the mass. You can measure the mass with something like a mass balance or some scale. And if you divide force and then mass, you got your gravitational field. So that is how you should be conducting an experiment to find the field. Now, the bulk of this unit, Newton's 3 laws. Newton's 3 laws, the first one is that an object at rest always stays at rest unless an external force acts on it. It also states that an object at constant velocity continues to move at that same velocity unless acted by an external force. So now an example for this might be a suitcase at the airport. If it's simply sitting on the ground, will it be moving? No, because it's at rest. We need an external force to move it, and that might be you or some passenger that picks up that suitcase or pulls it, and now it moves because of that external force. Now, Newton's second law brings us one of the most important equations of this course. F net, which is the net force, equals to ma, mass times acceleration. So a force acted on an object will lead to an acceleration. And now the third law states that for every action, there is an equal and opposite reaction. For example, if you apply a force on, let's say, a book, then that book will apply the same force back on you. Now, pretend you have a tennis ball in your hand, and you apply a force on it, right? The tennis ball will apply the same force back on you. But why don't you move as far back as the tennis ball? But if you hit the tennis ball with some force, the tennis ball goes flying. Now the reason is that even though the forces are the same by Newton's third law, but a tennis ball is going to be much lighter than you. which is why its acceleration will be much greater. Now there are two types of friction that you must be accustomed to: static friction and kinetic friction. So static friction is the friction force on an object that does not slide relative to a surface. And then kinetic friction is the friction force on an object that slides relative to a surface. And friction will be the coefficient of friction times normal force. And just remember that static coefficient of friction will be larger than the kinetic friction coefficient. And then it's very important for you to know, for example, pretend an object is at rest. Maybe it's on a rough surface, and you're trying to push the object, right? You're going to start by applying a force of 0, and you will slowly increase that force. Then suddenly, there will be this threshold of motion where that block starts to move. Before the threshold of motion, there was static friction. But once that force equals to the static friction, the maximum value of static friction, now it slides relative to the surface. And after that, there you go. Kinetic friction is what will be applied to the box. Free body diagrams are one of the most important things that you will ever learn in physics. This is one thing that will chase you for your entire physics journey, whether you're in electricity or magnetism, it's always there. In a free body diagram, you draw arrows to represent forces. Make sure to draw them in the right direction. For example, this image has a free body diagram from the book itself, directly from my book. For example, in block B, you can see how there's a gravitational force downwards. Remember, gravitational force is downwards. And then there's a tension force upwards. Label the forces and draw the arrows to represent the direction. Now, important information that people often confuse. A force is a vector. It's not a scalar. It's a vector. And acceleration will point in the same direction as the force. Now, if we have multiple objects in a system and you want to find the acceleration, then finding the acceleration of the center of mass can be useful. Working with the center of mass can be useful often, and you will see some examples for this in the book. Remember, if there is no external force on a system, then there is no acceleration, because we know by Newton's second law, net force equals to mass times acceleration. So zero force means zero acceleration. Now, let's practice this free response question from an actual EP exam. So please pause the video and try the problem on your own. So by now I hope that you actually read the problem and tried it, so let's look at the solution. So basically, in part A, right, we want to draw and label the forces acting on the package. So basically in this problem, there's a helicopter, right, and it's holding a 70 kilogram package that is suspended from a rope that is 5 meters long. And then this helicopter and package, right, both of them they're tied to each other and they're accelerating upwards at a rate of 5.2 meters per second squared. And then we want to label the forces that act on the package. So there will be a tension force upwards and then the gravitational force downwards. Now for part B, we want to determine the tension in the rope. So let's use Newton's second law. So we know that F net equals to ma. And then we can find that the net force is tension, which is upward, minus mg. T minus mg. And this equals to ma. And then we can add mg to both sides to get that tension equals to m times a plus g. And then we can substitute the acceleration, since we know it's 5.2, and then g is 9.8 and the mass is 70, to find that the tension is 1050 newtons. Now in part C it says, when the upward velocity of the helicopter is 30 meters per second, the rope is then cut, and then the helicopter continues to accelerate upwards at the rate of 5.2 meters per second squared. And then we want to determine the distance between the helicopter and the package 2 seconds after the rope is cut. So basically at this moment, right, the rope will be cut, and then the helicopter will continue to accelerate upwards with the same rate. Now the only difference is that the package will be accelerating downwards with g. So let's find the vertical displacement for the helicopter and the package. So for the helicopter, we know that the displacement equals to the initial velocity times time plus 1/2 at squared. So we know the initial velocity, right when the rope is cut, it's 30, and then the time is 2 seconds, 1/2 times, and then the acceleration is 5.2, and then t squared is just 2 squared. So we can add this up to get that the vertical displacement of the helicopter is 70.4 meters. Now let's work with the package. We use the same formula again. Now the only difference is that the initial velocity for the package is 30 meters per second upwards, but the gravitational acceleration g is opposing it. So we're going to be using minus 1/2 gt squared. So now we can plug in all of our variables to find that the package displaces by 40.4 meters. Now we can find the difference between 70.4 and 40.4 to find the net displacement between the package and the helicopter, and then we get the answer is 30 meters. Now let's look at another free response question from the actual AP exam. So please pause the video and try the problem on your own. So by now I hope that you actually pause the video to try the problem. So basically, there's two small blocks, each of mass m, and they're connected by a string, right? And the string has a constant length, 4h. And then block A is on a smooth tabletop, right? As you can see in this diagram above. And block B hangs over the edge of the table. And then the tabletop, right? The top of the table, it's a distance 2h above the floor. And then block B is then released from rest at a distance h above the floor at the time t equals to 0. And then we want to find the acceleration of block B as it descends. So let's use Newton's second law to find acceleration. So the forces on block B are there's gravitational force downwards and then there's tension force upwards from the rope. So we get mg minus t. That's the net force, and this equals to mass times acceleration. Now for block A, of course there's normal force and there's gravitational force on block A, but that's not going to be causing motion. It's tension force that will cause block A to move, and tension force equals to mass times acceleration for block A. Now we can add both of these equations to get mg equals to 2ma, and then we can divide both sides by 2m to get that the acceleration is g over 2. Now part B says that block B strikes the floor and it does not bounce, and then we want to determine the time t, right, at which block B strikes the floor. Well, let's think about this. We know that block B will displace a distance of h units, right, downward. And then its initial velocity will be 0 since everything is released at rest. And then we know that the acceleration is g over 2. So let's use the equation that the displacement equals to initial velocity times time plus 1/2 at squared. We plug in h for displacement, 0 for initial velocity, and then 1/2 g over 2 because g over 2 is the acceleration times t squared. And then we can simplify this to get that t squared equals to 4h over g, which means t equals to 2 times the square root of h over g. Now in part C, we want to describe the motion of block A from time t equals to 0 to the time when block B strikes the floor. Well, let's think about this. We know that block A also has an acceleration of g over 2 across the table. So this means that before block B strikes the table, that block A will continue to accelerate across the table with the same acceleration as block B. Now in part D, it says describe the motion of block A from the time block B strikes the floor to the time block A leaves the table. So when block B strikes the floor, tension force will no longer exist, and this means that block A will no longer be accelerating. And that means that acceleration is 0, so velocity is constant. So this means that block A will move at constant speed after block B strikes the floor. Now thank you so much for watching this video, and please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.